Have problem 8, thermite. Okay. Thermite is a mixture of iron oxide and aluminum powder. Okay, so let's find thermite. Okay. Oh, this is thermite. All right. So it is the one we use to wield railroad tracks. Okay, it is used in wielding, and it undergoes a spectacular reaction to yield solid aluminum oxide and molten iron. Okay, so let's have a reaction. Okay, let's write an equation in that. We have iron oxide. Okay, Fe. We have Fe because of a lot, and we have aluminum. Okay, Fe2O3 plus aluminum, which yields to aluminum oxide. Sorry. Oh no. Okay, which yields to aluminum oxide. El2O3 plus Fe. Now let's balance. 2, okay, and 2 here. Alright, so this is the equation. Iron oxide reacts with aluminum for us to form aluminum oxide and an iron. Okay. So we are asked in letter A how many grams of iron form when 135 grams of aluminum react. We are asked of the grams of iron. This one. Okay. When 135 grams of aluminum, if we have 135 grams here. Okay. All right, so grams. Okay, now let's use the given number 135 grams aluminum times. Okay. Next is the atomic mass. Okay, the atomic mass of we will use the equation. We will use this balanced equation. Okay, so we will write in 1 mole. Okay, since it's 2 here, aluminum. Okay, so 2 moles of aluminum is will also yield 2 moles. 2 mole Fe. Okay, so now we have Fe. Okay, and then mole aluminum. Okay. We are left with mole Fe. We are asked of grams. Okay, so we will use again the atomic mass. Atomic mass of Fe is 55.85 grams over mole. Okay, this is Fe. Okay, we can cancel mole, and then we are left with 55.85 grams. So that is equal to, okay, 274.45 grams Fe. Okay, so this is our final answer in letter A. 274.45 grams of Fe. Okay. So again, we use the 135 grams of aluminum, which is given, and then we use it. Okay, to cancel the grams, we use the atomic mass of aluminum, which is 26.98 grams, and then we are left with mole aluminum. Okay, for us to get the mole mole iron, because we are asked of iron, so we will use the equation. We will use this equation. iron oxide plus 2 aluminum, which yields to aluminum oxide, and then 2 iron. So we will use the, okay, 2 moles of aluminum is equal to 2 moles of Fe. So we use these factors, and then we are left with mole of Fe. So we are now happy, times mole of Fe times the concentration, 55.85 grams Fe, which is the atomic mass of Fe. And then simple math, just multiplication and division, we have 274.45 grams Fe. Okay, so let's go to letter B. How many atoms of aluminum react for every 1 gram of aluminum oxide formed? Okay, so we are asked of atoms. Okay, so remember, when we are asked of atoms, we use the Avogadro's number. Okay, so here, the given is 1 gram. Okay, so atom of aluminum is equal to, what is this? 1.0 grams aluminum oxide, Al2O3, times how many atoms of aluminum? Okay. All right. We are asked of the atoms here. So we have, okay, we will use atoms of aluminum. Wait. So we multiply it with the atomic mass of aluminum oxide. Okay, aluminum oxide is, since we have aluminum 26.98 times 2, since there are 2 atoms, plus oxygen, which is 16 times 3, since there are 3 atoms. So we have 101.96. Okay. So 101.96 grams of aluminum oxide, Al2O3, per mole. Per mole. Okay. And this is, okay, so we are left with mole. Then 1 mole of Al2O3 has 2 moles. Oh, has has 2 moles of aluminum. Okay. And then we are asked of atoms of aluminum. So let's continue. 1 mole aluminum is has 6.022 times 10 to the 23 atoms. Okay, atoms. Okay, so we are good. Grams, cancel, 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 cancel. Okay, 2 moles. So this is equal to 1.00 times 2 times 6.022 times 10 to the 23 divided by 101.96. So we have 1.18 times 10 to the 22 atoms aluminum. Okay. Yes. Okay. We are done. So in every 1 gram of aluminum oxide, there are 1.18 times 10 to the 22 atoms of aluminum that reacts.